Alright, so now I want us to go ahead and start looking at complex fractions, and there's two methods of simplifying complex fractions. So we'll look at each one individually, and then we'll kind of look at them together. So the first one here is method one. It says you want to simplify the numerator and denominator separately, divide by multiplying the numerator by the reciprocal of the denominator, and then of course simplify your resultant fraction. So really what this one says first make sure everything is factored. And so if we look at this example here, everything is factored. All the numerators and denominators are factored completely. And then step two is because we're dividing fractions, step two is that keep, change, flip part. So step two says just keep your top fraction y plus 2 over y, change that division multiplication, and then flip that bottom fraction. Alright, now that we've done that, now we just want to simplify. Well, again, I can cross simplify. Notice that my two y's would just cancel out. And so nothing else really cancels out. And so we're just left with 3 times y plus 2 on the top over the y minus 2 on the bottom. And that's our answer. That's our simplified fraction. So that's method one. Let's try one more problem using method one. Alright, so here we have 4 minus 3 over x over 5 minus 1 over x. So again, step one says simplify your numerator and simplify your denominator. So just the top part here, again, combining fractions. So I'm going to kind of show you. We just look at it individually. So for the top, my common denominator is x, so that becomes 4x over x. 3 is already over x, so that just stays 3 over x. So far that's the top. And then the bottom, same thing, x is my common denominator, so 5x over x minus 1 over x. Okay? And so, but we're not completely done now. Now, because they are both written over that same denominator, I can combine them a little further. So that becomes 4x minus 3 over x on the top, and on the bottom that becomes 5x minus 1 over x. Alright, and so that's step one of method one. It says you just want to take your numerators, take your denominators, and you want to simplify them as far as you can. And then step two now is the keep, change, flip part. So we're going to keep our first fraction, 4x minus 3 over x. I'm going to change that division multiplication. I'm just going to flip that second fraction, so 5x minus 1. Now we want to cross off any common factors they have. Well, they do have the two x's in common, so they cross off. And so on the top, we're left with 4x minus 3. And on the bottom, we're left with 5x minus 1. And again, check to see if you can simplify this, and we can't, so that is our final answer, 4x minus 3 over 5x minus 1. And so that's method one. So that's two problems using method one. And so now I want us to go ahead and get into looking at method two. Alright, so here we have method two of simplifying a complex fraction. It says step one is you want to multiply the numerator and denominator of the complex fraction by the least common denominator of the fractions in the numerator and the fractions in the denominator of the complex fraction. Then it simplifies. So what this says is you want to find all your denominators, okay? You find your denominator of every single fraction you have, and you want to find the LCD of that. And so if we look here, 2 and 3, they're both written over 1, you could say, and so you really don't have to worry about that. But so the LCD in this case for all your fractions is just y, okay? It's just y, and so now step one says once you find that LCD, now you want to multiply everything by that. So I'm going to multiply this whole top one by y. I'm going to multiply this whole bottom one by y. And so when I do that, we've got to distribute. So 2 times y is just 2y. Well, 1 over y times y, the y's cancel, just leaves me with 1. And then on the bottom, the y times 3 is 3y. And then again, the 2 over y times y, the y's again cancel just like they did up here. And so what happens is we're just left with the minus 2 there. And then that's our answer. If you notice, I can't simplify that any further. 2y plus 1 over 3y minus 2, that's simplified form, and so that becomes our answer. And so that's method two. So method one used a keep, change, flip method, whereas method two, you use your least common denominator and multiply everything by that. All right, so let's do one more method two problem, and then we'll put the two together. All right, so here we have 5 minus 2 over y over 4 plus 1 over y. And so again, first thing we want to do is we want to find that LCD. And then if I look for the LCD, I get that again, it's y. And so we multiply. So I'm going to write it a little differently this time. So I'm multiplying every single thing by the y. Every single term by the y. Alright, so when I do that, I get 5 times y, which is just 5y. And then I get 2 over y times y. Well, again, the y's cancel, and so we're just left with minus 2. And then on the bottom, we get y times 4, so we just get 4y. And then we get 1 over y times y. The y's cancel, and so we're just left with the plus 1. Again, nothing else. I can simplify there. It's in simplest form, and so that just becomes our fraction. So 5y minus 2 over 4y plus 1. Alright, so now I want us to look at another problem, and we're going to actually solve this problem using both methods so that we can kind of see how they compare. So the problem is 2 over x minus 3 over 5 over x squared minus 9, and so if you remember, method 1 says first you want to simplify the numerator and denominator completely, and so we look, everything's simplified for method 1, and so we're ready to keep, change, flip. So I'm going to keep the first fraction 2 over x minus 3, change my division to multiplication, and flip my second one, x squared minus 9 over 5. Now one thing to notice is that we know that x squared minus 9 is, if instead of using that, we can factor that out. So that factors into x plus 3, x minus 3, difference of squares, over 5. Alright, so now what we see is that the x minus 3's just cancel each other out. And so what we're left with is 2 times x plus 3 on the top, over 5 on the bottom. And that's our answer. That's as far as we can go. Okay, so that's method 1, again, using the keep, change, flip method. And so now let's look at this problem with method 2. Method 2 says you want to find your LCD. Okay, find your LCD and multiply everything by that. And so if we look for our LCD, okay, we've already established that x squared minus 9 was x plus 3, x minus 3, and so that actually is what happens to be our LCD, x plus 3, x minus 3. All right, so that's our LCD. So I'm going to rewrite the problem. So we got 2 over x minus 3 over 5 over. And I'm going to go ahead and just write this in its factored form, since that's what our denominator's in, our LCD is in. Okay. All right. And so now method 2 says you're going to take this LCD and you're going to multiply the top part of your fraction by it and the bottom part of your fraction by it. So I'm going to take this top part, I'm going to multiply it by x plus 3 times x minus 3. And then I'm going to take the bottom part and I'm going to multiply it by the same thing, x plus 3, x minus 3. Okay? And so what we see on top is that our x minus 3's, they cancel. And so on the top we're just left with 2 times x plus 3. And then on the bottom we see that the x plus 3, x minus 3 cancels with the x plus 3, x minus 3. And so on the bottom we're only left with a 5. And there we go. There's our answer. I can't simplify it any further. And one thing to notice, that's a really good thing, is that these two answers are the same. So it doesn't matter which method you use. You can use method 1 at any time. You can use method 2 at any time. You should still get the same answer as long as you perform the math calculations correctly. But I do think there are some problems where it may be better to use method 1 versus method 2, and some problems where it may be better to use method 2 versus method 1. Hopefully, as you practice these and start going through some of these problems, you'll pick up on when it's best to use which problem. But again, if you have any questions, just please feel free to get in touch with me and ask, and I'll be happy to work with some more problems through you. Thank you.